Hello everyone, my name is Meghna. My project is on cardiovascular disease prediction. So cardiovascular diseases generally refers to the condition in which there is the narrowing or the blockage of the blood vessels, which leads to the heart attack, chest pain or the stroke. And CVDs are the number one cause of death globally, and an estimated of about 17.9 million people died from CVDs in 2016. And most CVDs can be prevented by addressing the risk factors such as the tobacco use and obesity and physical activities, etc. The people who are at the risk of the CVD need earlier detection and management using the counseling and the medicines as appropriate. So this cardiovascular disease data set was obtained from the Kaggle website, which was collected during the medical examinations, and it consists of about 70,000 records and the patient's data. There are about 11 input features in which there are objective examination and the subjective features of the patients, and there is one output variable, that is the presence or the absence of the cardiovascular disease. So we'll talk about the data exploration now. So in that we have exploratory data plots and detection of outliers and the correlation analysis. So this is the exploratory data plots, and this is in between the height and the weight, and this is the high blood pressure and the weight, and this is low blood pressure and the weight. We can see that there is no correlations between these variables, and they are negative value here in these two plots, and there is a high a range of the values, which means that they are the outliers in the data. And this is the histogram of the continuous features in which the age shows the skewness in the data, and this bar plot summarizes the categorical variable in which we can see that the presence and the absence of the cardiovascular disease shown to have equally present in the data, and the smokers or the active smoker or the non-smoker are more in the data. And this is the alcohol consumption, cholesterol and the glucose variables in the data. So this is the box plot, which shows that they are outliers in the height, weight and the high blood pressure and low blood pressure variables. And this is the correlation or correlationality analysis, and from these numbers in the bubble plot we can say that there is absolutely no correlations in between the data, which means that we don't have any multicollinearity problems in the model. So next is the data imputation. The data set didn't had any missing values, so I removed some of the values by using prod NA functions, and then the impute by using the predictive mean matching method, and then I did the encodation of the data by cleaning the weight variables and height, weight, APHI and low blood pressure variables, and then the normalizations of the feature. So this is the function for normalizing the function, as there are the scales of the features was very high to low range, so the normalized function will make it as to from 0 to 1, and this is the code for the transformations of the data. So I'll run the normalization and the transformation for both the original and imputed data set. So this is the result for the transformation. So this is the original data, and this is the log transformation, and this is square root and inverse, and this four plots here shows the transformation for the imputed data set. When compared to all other transformation, the log transformation shows to decrease the skewness in the data, and hence the log transformation was applied. And then the dummy coding was done for the factor features, and then the PCA, using the PCA, the 13 features were selected, 14 features were selected as the input variables. And then this is the creations of the training and the validation data sets, and three samples for each was created in order to do the homogeneous learners. And then these are the models which were created, the KNN random forest and the regression tree models. This is the basic model, and this is the tuned model. So I'll run both of the models now. Oh, I didn't run the training sample. So now I'm running the tuned models. So all the models have run, and I have chosen the KNN model because this is a large data set, and KNN works very well on the large data, and it doesn't make any assumptions about the underlying data, and it's very simple, effective, and fast. And I have chosen another one as random forest because it can handle both categorical and continuous variables, and it also performs better on most of the problem, and it also select the important features. And regression tree is a combination of the strength of the decision trees, and it has an ability to model the numeric data, and it also selects the feature which is really important in the modeling. And the models have been tuned by passing the tuned length parameter as the 10 and the tune grid parameters. The KNN model has been tuned by passing various K values, and random forest model has been tuned by passing the grid width M3 parameter, and regression tree model is tuned by passing the grid with the maximum depth. And then the models have been evaluated by using the whole dot method by predicting the cases of the test data set. And all the models are made as a homogeneous learner by using the bagging here. And I'll just run the bagging. And here I have constructed the ensemble model in order to improve the performance. So this is the evaluation of a model with the k-fold cross validation. And we use accuracy as a measure because kappa is actually highly correlated with the overall accuracy. So reporting kappa is redundant with overall accuracy. So we can see that the random forest model shown to have higher accuracy in both the original and imputed data set, as well as the ensemble model of the ensemble model shown to have higher accuracy when compared to all the models with the single algorithm. And this is the interpretation in which the accuracy has been determined by using the confusion matrix. So here also the random forest model shown to have higher accuracy in the original tuned and imputed tuned dataset, except for the imputed dataset in which KNN shows to have the highest accuracy. And the homogeneous learner shown to have higher accuracy when compared to the models without homogeneous learner. And the ensemble model shown to have higher accuracy when compared to all the other models which we have built. And then this is the comparison of the model using the AUC sensitivity, specificity, and the precision values. So even here also the random forest model shown to have higher AUC and sensitivity, because the people who are at high risk of CVD is required to be informed. The ensemble model of the imputed and the original data set also shown to have the higher AUC and the sensitivity value. So now this is the interactive dashboard using the Shiny app. I'll run this. So here comes the screen in which if we submit, it will predict whether the cardiac disease is present or absent. We can change the values here to 2 and 7, 8, 9, 6 and cholesterol, yeah, like this. And if we submit, yeah, even this gives the absent results here. So looks like I gave the wrong gender default value, so I'll give this as 1 and then run again. So yeah, here we have the correct value, and if we submit, we'll get it as absent, and we can change the gender and cholesterol levels and the height, etc., and that will give us the prediction. So now, the conclusion, the random forest model shown to have higher accuracy when compared to the KNN and regression tree models, and the ensemble model has shown to have more accuracy when compared to single model as well as the homogeneous learning models, and a random forest and ensemble model of the original tuned data set has shown to have higher AUC sensitivity and precision value, and the tuned models have shown to have higher performance when compared to the other models, and also the imputed data set has shown to decrease the accuracy when compared to the original data set. Thank you.